Hello dear friends, my name is Afshin Haydari, and in today's video I'm going to solve an important problem about the concept of limit of functions using the epsilon-delta limit condition, a method to prove a limit conditional expression. Before I start this subject, I just wanted to invite you to subscribe to my channel and also let you know that you should ring the bell here. This will let you get any updates as well as new videos that I've created. Okay, so let's get started. Let's have a brief introduction. This is the precise definition of a limit. Let me consider the function of f of x here as y equals f of x be defined on an open interval about c, except possibly at c itself. C, I show this point as a hollow point, and it is located at the center of this open interval starting from c minus delta to c plus delta. This is an open interval except possibly at c itself. We say that the limit of f of x as x approaches c is the number L, and write like this. It means that if for every number, positive number such as epsilon, it's better to say that for every given positive number such as epsilon, there exists a corresponding number such as positive delta, delta greater than 0, such that for all x, absolute value of x minus c, which is greater than 0 and less than delta, as the result, the absolute value of f of x minus L is less than epsilon. Please don't forget that the concept of absolute value of, for example, x minus c is the distance between these two numbers here, and a distance cannot be negative, always is positive distance. Same as here. The distance between f of x and L is shown by the absolute value of f of x minus L. And by mathematics language, all of these should be written like this. This sign means for every given epsilon, there exists a positive delta, which if absolute value of x minus c is less than delta and greater than 0, as the result, absolute value of f of x minus L is less than epsilon. You should consider this graph as the relation of delta and epsilon in the definition of limit. When x move inside of this interval, this open interval, f of x will move inside of this open interval. We want to prove this by the definition of the limit. Based on epsilon delta definition of limit, we can write this. This is f of x, c, 2 is c, and L is 5. And we can write like this: for any positive given epsilon, there exists a delta greater than 0, which if absolute value of x minus 2 is greater than 0 and less than delta, as the result, f of x 2x in power 2 minus 3 minus 5. This is L here. This is L. And it is less than epsilon. Let we call this non-equation as P, and we call this one as Q. We should find a way to get to Q from P. How can we logically get to Q expression? Utilizing P expression. We should work on Q expression. Let's work on the Q expression. We will try to create P expression as a factor in Q expression. It means taking out P expression as a factor from Q expression. So working on Q expression. We start. to solve here. So we have absolute value of 2x2 minus 8 is less than epsilon, and by factorizing 2 out, we have 2 times absolute value of x2 minus 4 is less than epsilon. I forget write this epsilon here, sorry. You should consider an epsilon here. It is okay. And we have 2 times absolute value of x minus 2 multiplied by x plus 2. This is very simple. And less than epsilon. Obviously, it is so logical to write that this amount, this part, these terms, is equals or less than 2 times absolute value of x minus 2 multiplied by maximum of the absolute value of x plus 2. This is very logical. Let's assume that 2 times absolute value of x minus 2 multiplied by maximum of absolute value of x plus 2 is less than epsilon. Then logically the p expression, which is here, will be true as well. Now we need to compute the value of maximum of absolute value of x plus 2. As the assumption of the problem, we already know this is the p expression. We know this, we saw this before at previous page. As the result, when this distance, the distance between x and 2 is greater than 0, it means that x cannot be equal to, and about this part, it means that x between 2 plus delta, 2 minus delta and 2 plus delta. And as the result, we have this. We should add a2 to all sides. Why? Because we want to compute the value of maximum of absolute value of x plus 2. So we should build up x plus 2 here, and we add a2 to all sides to build up this expression. Now let's consider a positive amount for delta. For instance, we consider 1 for delta. Delta equals 1. So here we plug in this amount for delta, and we have this. X plus 2 is between 3 and 5. So the maximum value of absolute value of x plus 2 is 5. It means that if we consider an amount equal 1 for delta, as a result, the maximum amount of absolute value of x plus 2 will be equal of 5. Therefore, star. Therefore, in a star, this expression, by considering delta equals 1, by plugging 5 instead of this maximum, 2 times absolute value of x minus 2 multiplied by maximum of absolute value of 2 is less than epsilon. This is, we computed already, I've computed 5. So we have this 2 times 5, 10. 10 times absolute value of x minus 2 is less than epsilon. And as the result, the absolute value of x minus 2 is less than epsilon over 10. This is valid for p expression as well. We consider 1 for delta as the assumption here. Delta equals epsilon over 10 by this condition, when delta equals 1. So by operating reversely, we can get to Q via P, and we have found a way for this. Now let's have a quick explanation about this graph. You can see that f of x is 2x2 minus 3. This is the graph of this function, and about limit. This is C. X approaches 2. And the answer of the limit will be 5. As a matter of fact, 2 is a member of the domain of this function as well. So this function for 2 is defined, and f of 2 will be 5. We consider delta equals 1, so we have an open interval here starting from 1 to 3, and 2 is located at the center of this open interval. F of 3 is 15, and the distance between the answer of limit, which is 5, and 15 will be 10. I want that you have a sense, and f of 1 is -1 here, and the distance between 5 and this point is 6, but we choose epsilon over 10. We have chosen the bigger one. As the epsilon. Okay, my friends, I really hope this video has inspired you to think about concept of limit of a function adequately. Dear friends, if you are interested in my videos, please don't forget to subscribe in my channel and hit the like button and ring the bell as well to get a notification about my new videos. Thanks a lot and goodbye. Bye bye.